Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. On this video guys, I'll be tackling the 6th question from the media examination, which was written in the province of Eastern Cape in the year of 2024. Please do expect a total number of 7 videos, since the question paper had 7 questions in total, and that simply means each and every question will have its own video. And please guys, do take this seriously. I strongly believe that knowing how to tackle exam questions will give you an edge whenever you write your media exam, your preliminary exam, and most importantly, your final examination. So please do share the video to your peers so that they may have the same edge as well. And please guys, do help us grow the channel by just subscribing. Okay. We are told that initially 1 mole of sulfur dioxide and oxygen are allowed to react in a sealed container according to the balanced equation. The graph below shows the change in amounts of reactants and products over time. Obviously, the graph is not drawn to scale, no? Okay. Both of our reactants, guys, they had an initial amount of moles in at the beginning of the reaction. Né? They had 1 mole each. Are you together? But sulfur initially was not formed, so sulfur had 0 moles. And then as the reaction progressed, sulfur was able the reaction was able to produce more moles of sulfur. Are you together? Until the reaction got into time T1. Between time T1 and T2, I can see that there's no change in the amount of sulfur, there's no change in the amount of sulfur trioxide rather. There's no change also in the amount of my reactants. That only happens if and only if my reaction has reached a state of dynamic equilibrium. Are you together? So that only happens if our reaction reaches a state of dynamic equilibrium. Okay. Firstly, they want us to state Le Chatelier's principle in words. It simply states that when an equilibrium in a closed system is disturbed, the system will reinstate new equilibrium by favoring the reaction that will oppose the disturbance. Are you together? When equilibrium in a closed system is disturbed, the system will shift, or rather, we can say that the system will favor the reaction that will oppose the disturbance. Okay. How will the rate of the forward reaction compare to the rate of the reverse reaction between time T1 and T2? At time T1 and T2, I've already stated that we have dynamic equilibrium or chemical equilibrium there. Ne? So between times T1 and T2, the rate of the forward reaction is equal to the rate of the reverse reaction. Are you together? So they are just equal. Are you together? The reason is because the reaction has reached a state of chemical equilibrium. Which curve X or Y represents sulfur dioxide, and give a reason for your answer. Okay, according to this balanced equation, guys, you need 2 moles of sulfur dioxide to form 2 moles of sulfur trioxide, right? However, we need 1 mole of oxygen to form double the amount of sulfur trioxide. So that simply means that oxygen will be used up only half. We'll only need to use half the amount of oxygen to form the products. Are you together? But we will use almost all the amount of sulfur dioxide to form the products. Are you together? Since the ratio is simply 2:2. Are you together, guys? So this is why sulfur is represented by this other graph that has the lowest amount at equilibrium. So graph Y represents sulfur dioxide, and then X just represents our oxygen. Okay. And then now we are being asked, the temperature for the reaction mixture was decreased at time T2. Is the heat of the reaction positive or negative for the forward reaction? The heat, the enthalpy, guys, is negative, ne? Why is it negative? Let's go and check our graph. Okay, but before I go and check our graph, please note that, guys, a decrease in temperature. Did they decrease the temperature? Yes, they did. A decrease in temperature will always favor an exothermic reaction. Are you together? So if the fourth reaction is exothermic, that means the enthalpy is negative. Okay. Now let's check what happens after time t2. I can see that my reactants decreased. Are you together? Whenever, guys, my reactants are decreasing and I can see that the products have increased, this simply means that equilibrium has shifted to the right. Are you together? So it simply means that the forward reaction is favored. Are you together? A decrease in temperature favored the forward reaction in this particular reaction. Are you together, guys? So I can conclude that my forward reaction is exothermic. Why? Because a decrease in temperature will always favor an exothermic reaction. That's why the forward reaction is exothermic. Delta H is less than 0, ne? Okay. Let me repeat that. I said that in this case, guys, after decreasing temperature, our reactants decreased, which simply means our reactants were used to form products. Which simply means our reactants were used up to form products, and for us to use our reactants, that means we must favor the forward reaction. Are you together, guys? But I know for a fact that always the time, guys, a decrease in temperature will always favor an exothermic reaction. So since in this reaction a decrease in temperature favored the forward reaction, I can therefore conclude that the forward reaction is exothermic. And if the forward reaction is exothermic, the change in enthalpy for the forward reaction has to be negative. Always the time, guys, ne? The enthalpy for an exothermic reaction is negative, and enthalpy for an endothermic reaction is positive. Please don't forget that. Okay, now we are told that 2.5 moles of nitrosyl chloride was initially placed in a 1.5 cubic decimeter sealed container at 400 degrees. After equilibrium was established, it was found that 28% of nitrosyl chloride dissociated according to the balance equation. So since 28% dissociated, that means at equilibrium 72% of this amount is still available. Are you together? So the first question, they want us to calculate the equilibrium constant. Okay, for us to find the equilibrium constant, guys, we must know how to find the concentration at equilibrium. There is a table that always helps us to do so, ne? Okay, I have nitrosyl chloride, there's a 2 in front. Okay, and then what else do I have? I also have nitrogen monoxide, and then I'll also have my chlorine. I was told that I had 2.5 moles initially. Okay, let me just draw these over there. Okay, this part will represent my initial moles, the change in moles, the moles at equilibrium, and then over here I'll just have equilibrium concentration, number of moles over volume. Okay, initially, guys, I was given 2.5 moles of nitrosyl chloride, ne? But only 28% of it dissociated. That means 28% of my nitrosyl chloride was used to form products. Are you together? So I'll simply say 2.5 multiplied by 28%. Let's see what we find. 2.5 multiplied by 28%. This will simply give me 0.7. That means, guys, I have used 0.7 moles of my nitrosyl chloride. 0.7 moles were used of my nitrosyl chloride. Are you together? Then if, guys, initially I had 2.5, Initially I had 2.5, but I only used 0.7. That means I'll be left with 1.8 at equilibrium. Are you together? So now let's go and find the amount of nitrogen monoxide and chlorine that were produced. Okay, I know that 2 moles of nitrosyl chloride will simply give me 2 moles of nitrogen monoxide. Are you together? So, but this time around, guys, I've only used 0.7 moles of nitrosyl chloride. I want to know how many moles of nitrogen monoxide will I form. I'll just cross multiply. 2 multiplied by 0.7 is just 1.4 is equal to 2x. Then x is basically 0.7. So over here, guys, I have formed 0.7 moles of nitrogen monoxide. Let's go and find the number of moles of chlorine that were formed. I know that 2 moles of nitrosyl chloride will always give me 1 mole of chlorine. But this time around, I've only used 0.7 moles of nitrosyl chloride rather. I want to know how much of the chlorine will I form. Just cross multiply, then 0.7 will be equal to 2x. Therefore, x is basically 0.7 divided by 2 is just 0.35 moles. So over here, I simply have 0.35. That was produced. Are we together? But remember that, guys, initially products were not formed. That's why I'll have 0 over there and 0 over there. Ne? Okay, now let's go to our moles at equilibrium. For my nitrogen monoxide, initially I had 0, but now I've produced 0.7. That means at equilibrium, I'll also have 0.7 moles. Same applies to my chlorine. Initially I had 0, but the reaction produced 0.35. That means at equilibrium, I'll simply have 0.35. Are you together? And then for us to find the volume, I'll simply say 1.8 divided by 1,5 for me to find the volume of nitrosyl chloride. And then the volume of nitrogen monoxide is just 0.7 divided by 1.5, then 0.35 divided by 1.5. This will just give me the volume, right? So 1.8 divided by 1.5. Remember that, guys, the 1.5, I'm not guessing it. I was given the 1.5. I was given the 1.5 over there, ne? The volume of my reaction container. 0.7 divided by 1.5. This will just give me 0.47. And then I have 0.35 divided by 1.5. That will just give me 0.23. So now I do know the concentration of my reactants and my products at equilibrium. Therefore, I can simply find the Kc. The Kc, guys, is just the concentration of products. It's just the ratio of the concentration of products to the ratio of to the concentration of reactants. Are you together? For my products, I simply have chlorine as well as nitrogen monoxide. Ne? Please note that, guys, the exponent is always the stoichiometric coefficients. Are you together? For chlorine, the coefficient was 1, so I don't need to write the power 1 over there. Ne? But for nitrogen monoxide, I will write squared over there, as well as for nitrosyl chloride, I will write the exponent over there. Chlorine was just 0.23. Nitrogen monoxide was 0.7 all squared. And then for nitrosyl chloride, I had 1.2 all squared. Then this will give you my equilibrium constant. 0.23 multiplied by 0.7 squared all over 1.2 squared. So this will just give me 0.03528. If ever I round off to, let me just round off to 2 decimal, to 2 significant figures. Okay, this is my answer, guys. Now, the equilibrium constant is basically 0.035. That's how, guys, you're supposed to tackle this question over there. And then now for 6.2.2, we are being told that more nitrosyl chloride is added to the equilibrium mixture. How will this change affect the equilibrium constant? This will have no effect, guys. Are you together? Equilibrium constant can only be tempered by a temperature. If we change the temperature, definitely the equilibrium constant will also change. The equilibrium constant will also change. Yeah? So over here, this will just remain the same, because whenever we add more amount, that will never change the equilibrium constant. Only temperature can affect equilibrium constant. The other factors do not affect equilibrium constant, but they do affect the rate of reaction, but not equilibrium constant. So yeah, guys, that's how you're supposed to tackle this question over here. So please do stay tuned and wait for more videos. Thank you.